Okay, hopefully this is recording. We'll see. It says it. Now, here's your graph for the inverse sine function or the arc sine. And what that gives us is the portion that would be in quadrant 1 and quadrant 4. And these are going to be some of the key values that we would recognize if we use our quadrantal angles, negative pi over 2, 0, positive pi over 2, and then we're also using a negative pi over 4 and a positive pi over 4. So I don't know why this thing doesn't want to zoom in. I'm so sorry. Hopefully you can see it okay. But let's write down the key information that we know. Remember, inverse means we have switched x's and y's. So the domain on the original is now the range on the inverse and vice versa. So what would be the domain if we're talking about the inverse sine? That would be the ratios that come out of sine. It's got to be between what and what? Negative 1 and positive 1. What would be my range? Yes, we wrote it as negative pi over 2 to positive pi over 2. Okay, if I'm looking at this graph, would you tell me that this is increasing or decreasing? It is increasing on the open interval. Now use the x values because we always give intervals over the domain where it's increasing. So what would I write here? It increases from x values of -1. Good, -1 to 1. And would it be continuous everywhere? Yes, we don't have any holes, we don't have any gaps, starts, stops. So -1 to +1. What would be the x and y intercept? Where's the only place it's going to cross either axis? 0, 0, the origin. Would you say we have some symmetry here? We've talked about two kinds of symmetry. We check to see if we are symmetric to the y-axis, because if it's symmetric to the y, that means we have what kind of function, even or odd? Even. And the other kind of symmetry is symmetry with respect to the, and that would be odd. What do you think this is? Do I have any symmetry? I can't fold it over. Could I put a pin here and spin it 180 and would it look the same? That means I have symmetry to the origin, and that makes it an odd function. And when it's an odd function, it means that if I were to change the sign, S-I-G-N, of the angle measure, it changes the sign of the output. So in other words, sine, if I were to put in a positive value for an, let's say we did sine of positive pi over 4. In the first quadrant, the sign would be a positive number. If I put a negative in front of that angle measure, it takes it down to the fourth quadrant. What does that do to the SIG then, the front answer? It makes it negative. It changes the sign of the y, okay? So, and that rule is here on your even odd formula sheet, that having a negative angle measure changes the output to be negative. Now, let's talk about inverse cosine, okay? And this, again, did not print out exactly right, and this is going to be a pi. But we already discussed the fact that since cosine is negative in the second quadrant, we would want to restrict our function to be quadrants 1 and 2 with cosine. So we get values that are positive in the first quadrant, negative in the second quadrant. And remember, anytime you see the little -1, that does not mean raise it to the -1 power. That is saying you want the inverse cosine or the arc cosine, which the best way to think of it is I'm looking for the angle whose cosine is whatever x is. Okay? Now, talk to me about domain. What would have to be the domain on the arc cosine? Remember, that's going to be the original output values for cosine. So all my cosine ratios are between what and what? That's it. Same domain as it was with the sine, but the range is now different because we're going to go from where to where. Instead of quadrants 1 and 4, we're doing 1 and 2. So how would I write that? From 0 to, well, that would be, yeah, to pi. Pi over 2 would just be 90 degrees. If I want to do quadrants 1 and 2, I'm going to go from 0 to pi. Okay, so all of these are going to get restricted either from negative pi over 2 to positive pi over 2 if you're using 1 and 4, or from 0 to pi if you're using 1 and 2. Now, see if you can figure this out. If I asked you for the angle whose cosine is 0, what would that be? Staying in that restriction. Okay, so you say 90 degrees. If I were to put it in terms of radians, that would be what? It'd be what?
I was thinking of the other way, that it's cosine, it's in 1 and 2, right?
Mm-hmm. Well, and let's think of it this way. With cosine, is it a hala or hala? Hala. Because we start high, right? Okay, so that means that's a 1, that's a 0, correct? So which, if we start high, this is going to be an angle measure of 0. This is what? 90, which is pi over 2. Right? Does that make sense? You're just kind of thinking backwards is all you're doing. Now, ooh, how about this? We want, and I think that is a typo because we have not talked about cotangent yet. So let's write this as the arc cosine, or the angle whose cosine is 1/2. Now, where would I be? Which quadrant if my cosine is 1/2? Cosine's restricted to which 2 quadrants? 1 and 2. So if it's positive, I've got to be in which quadrant? All right, so if I draw myself a triangle in quadrant 1, and cosine is what over what? Adjacent over hypotenuse. Okay, does this look like a special right triangle? It does. And this side would be square root of 3. So what would be the angle measure whose cosine is 1/2? Very good. That would be 60 degrees, which is pi over 3. Does that make sense? Yes, no? What do you think? You just got to think backwards. If you know what the ratio is, you got to figure out which angle would give you that value. Okay? So let's sum up what we know about inverse cosine or arc cosine. This is what the graph looks like. Okay? That's when you're restricted to quadrants 1 and 2. We still have a domain that goes from -1 to +1, but look at that. Everything is up above the x-axis. And so our domain is -1 to +1. The range is what? 0 to just pi, right? Okay. Now, is this increasing or decreasing? Decreasing. And is it decreasing over the whole thing? Yes. So it's over, what would be the interval of the domain where it's decreasing? Except let's change the order. You got to go from least to greatest. -1 to +1 would be the interval where it's decreasing. Is it continuous everywhere? Yes, it is. So -1 to +1. Okay, tell me about X-Intercept. Do I have one? Is there some point that's on the x-axis that belongs to this graph? It's when x is positive 1, what's the y value? 0. So it's the ordered pair 1, 0. What would be my y-intercept? When x is 0, my y value is pi over 2. Good job. Okay. And do you see any symmetry? Is it symmetric to the y-axis? If I fold on the y-axis, will the halves match? No. Is it symmetric to the origin? No. I do not have symmetry with respect either to the y-axis or the origin. That means this thing's not even or odd. Okay? All right. So sine and cosine, we have now looked at their inverse functions. Okay? Let's look at tangent. Now, this is our symbol, obviously, for inverse tangent. We can also write it as arc tangent. It means we're going to look for the angle whose tangent is some ratio. But think with me for a minute. Where do we need to restrict tangent? Is it going to be quadrants 1 and 2 or 1 and 4? Okay, now if I were to ask you, is it negative in both quadrant 2 and in quadrant 4, what would you say? It is, isn't it? Because the only other place that tangent is positive is quadrant 3. So how do I decide whether I want quadrant 1 and 2 or 1 and 4? Here's how. You know how tangent has those vertical asymptotes? I need to know where they are, because I want to make sure I pick the interval that is between asymptotes. I don't want to have a missing value in the middle. Does that make sense? Okay, so here's how you can figure out if you don't remember. Tangent is the same thing as sine over cosine, right? Now, where I'm going to have an asymptote would be what value would make my denominator what? Oh, come on. What is the value in the denominator that causes me to have an asymptote? When the denominator becomes 0. So I need to know where cosine theta would be 0 to know where my vertical asymptote would be. Does that make sense? This is how I'm going to decide if I want quadrants 1 and 2 or 1 and 4. So at what value is the cosine going to give me 0 for my ratio? Cosine of what angle would be 0? I think we just did this one. Yeah, what it was? It's pi over 2. So that means I've got a vertical asymptote at pi over 2. So would I want to use quadrants 1 and 2 or 1 and 4? 1 and 4, because I've got a vertical asymptote that's going to split 1 and 2. And that means there's a value that doesn't exist. Does that make sense? Because what I want to get is a full cycle of my curve. So that's why tangent is going to be between negative pi over 2 and positive pi over 2. Now, you can memorize that, or you can think about it and see why that's going to be what we choose, okay? And we already know that when we see this or this, we're going to be thinking of the angle whose tangent is something. Now, talk to me about domain. Since I've already figured out I've got to be between negative pi over 2 and positive pi over 2 for the quadrants that I'm working with, talk to me about what the ratios are that come back out. And think about what that tangent curve does. Remember, isn't it the one that kind of looks like the cubic? Okay, so if I know what the range is on the tangent, that's going to be my domain on the arc tangent. So what would you tell me is the range on that tangent curve? Does it have any restrictions? Or does it go unbounded? So what would that make my domain on the tangent, arc tangent? That is correct. Because what is, you'll see it in just a second, what it's going to look like. But remember, I'm switching the x's and the y's. But my range is going to come back to what this restriction was here, because I restricted my domain in the tangent in order to make sure this thing would be a function when I took the arctangent. So from negative pi over 2 to positive pi over 2, because that's where those asymptotes occur, okay? Now, here's your graph. You know how this is what, let's see. Well, we know that the tangent looks like this. When we switch the x's and y's, it does this, okay? It sort of makes it, instead of an S-curve switched out, stretch out vertically, it makes it stretch out horizontally. So tell me again, that domain on this has got to be what? To positive infinity. My range is going to be between what and what? And by the way, do you notice that these are using parentheses and not brackets? Why would that be the case? There you go. That's where the asymptotes are. So those values are not included. It's everything between those values. Does this look like it's increasing or decreasing? It is increasing on the entire domain, which means from negative infinity to positive infinity. And is it continuous everywhere? Yes, that's why it's important that we make sure we pick the quadrant that doesn't have the asymptote in it. We want this section to be continuous. Tell me about X-intercept, Y-intercept. What would it be? Yeah, it's at the origin, 0, 0. Do you see any symmetry for this one? What would you say there's symmetry to? Very good. It has that rotational symmetry. So it is symmetric to the origin, and that means it's what kind of function? Odd. Excellent. So for all of the x values in the domain, that would mean that if it's odd, when I put the negative angle measure in, then what happens to the y value? It becomes negative. Very good. It becomes negative arctangent of angle x. That's using one of those even odd properties. And we have horizontal asymptotes. Where do they occur? What would this line be? And because it's a line, I've got to use it an x equal or a y equal? Which axis does it cross? It crosses y. So this is y equals negative pi over 2 and y equals positive pi over 2. Those are my horizontal asymptotes. Okay. Could we go through and figure out how to do the same thing with cotangent? Absolutely. But you get the idea of how you can develop these key features, let's put it that way, for each of these inverse properties. Now, this is just going to kind of sum it up for us. If we were talking about cotangent and we wanted to take the arc cotangent, we're going to need which quadrants, 1 and 4 or 1 and 2? Do you remember where the asymptotes are on cotangent? If you don't, then think of it as cosine over sine. What angle measure gives you a sine ratio of 0? 0 and pi. So in other words, we want to keep this restricted to quadrants 1 and 2 because that's where the asymptotes are. It'll be continuous if I go from 0 to pi. Now, secant is, remember, if I'm looking at the graph of secant, that's like those series of parabolas that just touch where cosine has a high point or cosine has a low point. And so if we were going to take those, we would also want to try to have the section that would give us all the values that we need. Now, we do have a little problem with this one because we have gaps. It's not going to be continuous. There's no way to get it to be continuous. And so in order to get all of the pieces that we would need, we're going to restrict it this way. Secant whenever you take the arc secant, is going to be for y values that are between 0 and pi, as long as you don't use pi over 2, because we do have a horizontal asymptote there. But notice if we go this way, we'll get all of the potential y values between pi over 2 and pi, and then this asymptote lets us get all of the potential y values between 0 and pi over 2, okay? There's just no way to get this one to be continuous. And for the arc cosecant, again, that's the one that would also be a series of parabolas, but it touches at the high points and low points of which function? Sine, because it's the reciprocal of sine. And so this is going to restrict it to where you're going to have negative pi over 2 is less than or equal to y, which is less than or equal to a positive pi over 2. In other words, we take quadrants 1 and 2, but we make sure we realize y cannot equal 0, because that's where it's going to be undefined. Okay, but that will give us all of the potential y values by doing it that way. So if we were to sum up what we should know about these, tell me about domain on arc sine. It's from -1 to 1. And that would mean that the range goes from negative pi over 2 to pi over 2. And is that included? Do I need brackets or parentheses? Brackets. Those are included, which means we're in quadrants 1 and 4. Good. All right. Arc cosine. What's the domain? -1 to 1. What's the range? 0 to pi, because we want to use which quadrants? 1 and 2. Very good. Okay. Arc tangent. Our domain changes on this one. It becomes what? Yes, negative infinity to positive infinity. And the range will be from where to where on arc tangent.
Negative pi over 2.
Negative pi over 2 to positive pi over 2. If in this one, we've got to make sure we leave it open. Here's what I would kind of picture. If you can remember the graph of tangent, is that cubic and it actually crosses at the origin. That's how you know that you're not going to go quadrants 1 and 2, because 0 is on the graph. You've got to go from a negative pi over 2 to a positive pi over 2. And then cotangent is shifted over, and that's why it will be from 0 to pi. Okay, but if you can kind of picture those graphs, it helps. So this is quadrants 1 and 4, where cotangent domain is negative infinity to positive infinity, but our interval will be from 0 to pi. Very good. And that means we're in quadrants 1 and 2. Okay, and these are going to be the ones that have a value that we have to skip. And so if you look back at these graphs, okay, look at arc secant. I've got a gap here for my x values. What is not included? Do you see a gap between -1 and +1? Remember when we talked about this before, that since sine and cosine can only go from -1 to +1, that means that secant and cosecant have all the other values. The only place that they share a point is that high point or that low point. So our domain is going to be everything except we've got to skip between a -1 and a +1. Okay, and if you look at that graph, you can see this goes on forever until it gets to -1. We've got a gap. It starts back up at +1 and goes on forever. Okay, now the interval where we have this is restricted from where to where. Since secant is the reciprocal of cosine, wouldn't it make sense that this would be the same, except what's the one thing we can't include? Remember, we've got a horizontal asymptote. Where is it? Pi/2. So we're going to go from 0 to pi/2, close that with a parentheses, and then go from pi/2 to pi. Don't get too panic-stricken. You're not going to get a lot of questions. You're not going to get questions like this on the test. This is just kind of making sure you put the pieces together. And that means we're in quadrants what? 1 and 2, right? And then for cosecant, see if you can tell me what you would fill in here. Is my domain going to be the same, or is it going to look different? This arc secant. It's the same. So it's from -infinity to -1, close bracket, union, 1 to +infinity. But I think my range is different. Do you remember what the restrictions are on arc cosecant? Cosecant's the reciprocal of sine. So it ought to be the same as this, except what is the value we can't include? Well, it goes from -pi/2 to +pi/2, but where's that horizontal asymptote going to be? Look at your graph. Where's your horizontal asymptote? Yeah, when you have a y value of 0. So we're going to go from -pi/2 to 0. We can't include 0, and then from 0 to a +pi/2, which means we're in quadrants 1 and 4. So notice it divides out evenly. You get 3 that are in quadrants 1 and 2, and 3 that are in quadrants 1 and 4. All right, that's when we're using those arc trig functions. Now, can we find the degree measure, excuse me, of angle Q if it exists? Remember, sometimes they give us things just to see if we're paying attention that really aren't in the domain. So we're looking for the angle whose tangent is the square root of 3. Now, if we're talking tangent, and that's a positive ratio, this should be easy. Which quadrant am I in? I got to be in quadrant 1. And tangent is what over what? I'm sorry, say that again. Well, it is sine over cosine, but if I'm just opposite over adjacent. So that would mean this side would be square root of 3, and then the adjacent would have to be what? Good. Okay, does this look like a special right triangle? It sure does. What would this angle measure be? Across from the square root of 3 means this has to be 60 degrees. So Q is 60 degrees, or if I put it in radians, that would be pi/3. Good job. Okay. Now, talk to me about this one. I want the angle whose cosecant is a negative square root of 2. All right, if cosecant has a negative ratio, which quadrant am I in? I'd have to be in quadrant 4, right? Okay, so cosecant is what over what? Hypotenuse over opposite, because it's the reciprocal of sine. So if I can think what sine is, then I'll reciprocate it. So since it is hypotenuse, which is square root of 2 over opposite, and since this is the angle measure, that would mean this side is how much? Okay, does that look like a special right triangle? What would it be? Oh, be careful.
45.
That is a 45. Now, it could be either a negative 45 degrees, or if I wrote it as a positive, that would be 315 degrees, or I could make it a negative pi over 4, or I could turn it into a positive ratio as well. All right, so far are we okay? All right, look at the next page. If you need to evaluate something on a calculator because maybe it's not a special right triangle, you look at it and you go, whoops, I don't recognize this guy. Then this is telling you how you're going to type it in, because remember, you have an arc sine button, you have an arc cosine button, and you have an arc tangent. What if you needed to get arc secant? What would you have to do? Megan, would you not close the door? Yeah, you would need, since it would be the reciprocal of cosine, then you could do the arc cosine of 1 over that angle measure, okay? And then arc cosecant would be, you would have to use the reciprocal for sine, okay? And then cotangent, you could use the reciprocal of tangent as well. So let's see if we can calculate this. I want to find the angle whose secant is -4. Now, how do you think we're going to find that? I'm going to have to use what button?
Second cosine.
And then we would put in, yeah, if I do second cosine, and then for the angle measure, I put 1 over, because I'm doing the reciprocal of the angle. Oops, you can't see that very well. So I would get 1 point, and it,
Does it have to be in degree mode? Because that's what it says here.
oh, it says find it in radians. Let me double check.
Oh, fine.
So
Well,
if, yeah, I'm in radians. And yes, that is good for pointing that out, Elizabeth, because you do need to make sure you're in the right, yeah, right mode. So 1.82347 ... depending on what it tells you to round to in the computer, that would be how you would round, okay? Now, what about this one? See if you can tell me what would be the angle whose cotangent is this. I'm going to give you a second to see if you can put it in. And notice it says in degrees. So if you just did the last one in radians, you're going to have to go into mode and change it. You guys got it? What are you getting? Anybody else get that? Very good. -75.813 degrees. We'll just round it there. Okay? Now, it says be careful when using a calculator to evaluate the inverse cotangent of a negative quantity. You have to enter the inverse tangent of the reciprocal of the negative quantity, which returns an angle in quadrant 4, because inverse cotangent is in quadrant 4, sorry, because inverse cotangent is negative in quadrant 2. You've got to adjust the calculator result by adding 180 degrees or pi accordingly. Okay, so we have actually not finished this thing, because notice, and here's what it's saying, since you have your relationship between tangent and cotangent not only flipping but also shifting, because remember with cotangent, you have your vertical asymptotes at 0 and pi instead of -pi over 2 and +pi over 2. When you flip it, you've also got to remember that it's got to shift. So what it's telling us is we're not done. We've got to go back and we're going to have to add 180 degrees to it, which is going to give us what? I think it's like 104.187 degrees if we were to round that. Okay, so that one's sneaky. You'll have to think about it. The others shouldn't be a problem, but that one will. Okay.
So
if
it'll just be when it's the cotangent.
Say that one more time.
When we have to add the 180, it'll just be when it's the arc cotangent.
Right, because if it was an arc tangent, the calculator has that button, so it's good. It's just if you need to get an arc cotangent that you'll have to remember once you've calculated it, you got to add 180 because you got to shift over for the difference in where those asymptotes are.
So you don't have to do that.
No, because it takes care of itself because you're already using the arc sine and there's no shifting between those two. Okay, now evaluate these without using a calculator. Here's what this is saying, and I know this goofy stuff, I don't know why it does that. Those are really just supposed to be parentheses, but it's asking you to find the cosine of the angle whose sine ratio is 2/3. Okay, I do not know how you do this without drawing a triangle. So I need to draw a triangle whose sine ratio is 2/3. Well, sine is what over what? So opposite would be 2, hypotenuse would be 3, and now I'm supposed to find the cosine of the triangle that has this sine ratio of 2/3. What would I have to do to find that? Exactly. I got to find this side length. So x squared plus 2 squared equals 3 squared.
It's fine. Yeah, because you subtract the 9 minus 4.
Yes. And so if x squared equals 5, that means this is the square root of 5. And now you can tell me that cosine value is square root of 5/3. Okay. Now let's see if you guys can keep up with this one. I know this looks like such a mess. Okay. So this is asking us to find the secant of the angle whose cotangent is a -15/8. Now, are we going to need to draw anything? Please say yes. Yes. Okay. I need a triangle because otherwise I'm going to be chasing my tail. I will anyway. So I start with whatever this inner function is. I'm looking for the angle whose cotangent is a -15/8. Okay. Think it through. Which quadrant would a cotangent be negative? Well, it's either 2 or 4, but think about your restrictions. Where are we restricting it to? Okay, picture your cotangent graph. Where's your vertical asymptote? If you don't remember, look back at your table. Cotangent's got to be which quadrants? 1 and 2. Okay, so this is going to end up being in quadrant 2. That's going to be important because that may impact the SIGN that I get on the outer part. So I want the angle whose cotangent is -15/8. Cotangent is what over what? Adjacent over opposite. So I've got an adjacent, and that's going to be 15. Does that need to be the positive or the negative? That's the negative. The opposite would be 8. And I want to get the secant for this triangle. Now, secant is adjacent, or is what? Hypotenuse over adjacent. So I got to get this hypotenuse value. Can you calculate that for me? Very good. So using Pythagorean theorem, 8 squared plus -15 squared equals x squared. And that's how we would get 17. Now looking at my triangle, what would be the secant of that?
-17/2.
Ta-da, you did it. Okay. We're almost done. We're going to see if we can wrap this up real quick, and then we'll be ready to do 7-6 when you guys come back. Okay, so this says evaluate without using a calculator. So give me some ideas on what you might want to do first.
Draw 2 triangles.
Excellent idea. Draw 2 triangles. So these are both positive ratios, so I'm pretty confident these are going to be in the first quadrant. So I just need to draw 2 triangles here. And since I want the angle whose tangent is 4/3, tangent is
Opposite ranges.
okay. And then I want the angle whose cosine is 12/13, and cosine is adjacent over hypotenuse. Okay, so we need to fill in these missing values, you think?
The first one, the hypotenuse is 5.
Okay, so the hypotenuse is 5. That's a Pythagorean triple. This one's also Pythagorean triple. What do you get?
5.
5. Okay, now here's the part that you got to be careful about. The angle whose tangent is 4/3. I know what my side ratios are, but I don't know my angle measure. Do you? I mean, that's not a special right triangle, so I can't put in an angle value. Same thing here. What would I maybe need to do then if I were going to make some kind of replacement? Look at this. I've got the sine of something minus something.
Could you, turn it into radians?
No, I don't want to do that. Doesn't this kind of look like a sum or difference identity? If this were an A minus B? Do you see what I'm saying? The fact that this is arctan of 4/3, it's an angle whose tangent is this. That's an angle. This is a different angle. This is the sine of angle A minus B. Can't we use that difference identity? But tangent's not going to be, see what I'm saying? Remember, arctangent is an angle, because I'm looking for the angle whose tangent is this. I just don't know what it is, but it'll be A, okay? So this is angle A. This is angle B. And if I use this identity over here, and I want the sine of A minus B, so that means I'm going to use the lower SIGN. I'm going to get the sine of, and we'll put in A, times the cosine of B minus the cosine of A times the sine of B. Does that make sense? Because now, could I look at my triangle and get a ratio for the sine of angle A? I can. What would it be? 4/5. That's it. Now I can replace that with 4/5. What would be the cosine on angle B? 12/13. Minus, now let's go back to this one. The cosine on this one is 3/5. And the sine on this one is 5/13, right? And then I just would have to multiply, clean up, and see what I come up with. All right, so there's a little bit of thinking outside the box that needs to go on in order to put it into a form I can work with. And I think we're out of time. So we will stop there. Probably the only thing we'll do with this when we come back, because we're not going to do this one, we'll just double check on the cleanup to make sure we don't have any problems there. We might look at this one, and then we'll be ready to do 7-6. Okay?